My name is Alison Mears, and I'm co-director and co-founder of Healthy Materials Lab at Parsons School of Design. And I'm here with my colleague.
I'm Jonsara Ruth. I'm also co-founder and co-director of Healthy Materials Lab with Alison. And we are delighted to be with you today. We wish we could be with you in person, but happy to contribute to this amazing event in Pittsburgh. Thank you to Leslie and Destiny from Green Building Alliance for the invitation to speak with you all. We've been speaking with her since this summer, and I'm looking forward to this event. And we're really sorry not to be with you all in person. But we are happy to be included with our old friends and colleagues in the PA Hemp Home and in this Hemplime movement across the country. Lori Daitner for her leadership, Cameron McIntosh for his expertise, Dr. Ali Mamari, Drew, and Anna at Coexist. I'm sure it's going to be a great gathering today. So we'll share some slides and give you a little bit from our perspective.
I'm going to start, and then Jonsara will finish up for this with the slides. So we, like you, probably see ourselves at an inflection point. We cannot continue to evolve the same trajectory that Western civilization has mapped for hundreds of years. What is the pathway forward? How can we design and build healthy buildings today? These are the defining questions at Healthy Materials Lab. We think one of the answers lies in the use of Hemplime, a healthy and high-performing insulation alternative to more toxic alternatives. The petroleum-based products in common buildings today that contain a vast array of untested, often toxic chemicals that consume and emit carbon. The polymeric materials like plastics, rubbers, thermoplastics, adhesives, foams, paints, and sealants show the highest growth rate in construction materials and in consumer products. These materials contribute greenhouse gas emissions during their production and are toxic in use. We assume that the materials we buy have been tested for safety, but most chemicals commonly used in building and consumer products in the United States are not regulated for their impact on human health or the environment. Only 250 of the more than 86,000 chemicals currently in use are tested, and only 5 have been partially restricted by law. These chemicals have a profound impact on human health and the planet. Research like Mount Sinai Institute's exposomic research has revealed that the ingredients used to make the products we build, which are threatening our health. There's evidence that the same ingredients found in building products are now found in human blood, linked to many diseases which are increasingly impacting communities. We live with the toxic and carbon implications of our decisions over the last century. We're surrounded by petrochemically derived products in industrialized foods, in packaging, building products, and many consumer products. If we live in a frontline community, we're surrounded both inside our houses and in the outside environment with a range of pollutants, including both CO2 emissions and other pollutants. So we as architects and designers are confronted by these problems, and we try to make sense of it. And by understanding what's inside every material we use, we can start to eliminate toxics in the built environment that impact people's health. We call this kind of thinking material health thinking, making a habit to be curious about the composition of a material and always asking, what's it made of? It's a new practice for designers to ask these deep material questions, which sometimes involve chemistry or health sciences, and to make these queries a habit. So we begin with that, what's it made of? And then how is it made? Where is it made? Does it require finishes? How will it be installed? Who will be exposed? Where does it go at the end of its useful life? And who's impacted throughout the entire life cycle of the material? This list of simple material questions are incorporated into our teaching and into our practice of design. And we bring this kind of thinking as foundational to our understanding of what we do in the research, in materials research. And so we begin with simple structures like housing, because a healthy home just determines many of the positive health outcomes in a person's life. In a typical residential wall in the US, there are many layers of building products, which often contain toxics. We're eager for healthier building systems to become the norm. We embarked into research about the history of hemp in North America, beginning in around 2017. We understand that the farming of hemp did not begin in 2018, but hemp has been cultivated and used by indigenous nations long before the colonizers reached the Americas. Here we see Alex White Plume, and he, like others, like Winona LaDuke and Earl Pendleton, have been advocating and cultivating and using hemp long before its recent legislation, and working on innovative production models to provide markets for crops. We also acknowledge early in American history that essential knowledge about how to work with the tough hemp plant was embodied in enslaved people. After emancipation, this knowledge was often lost. Our research closely aligned with Laurie Daytner and Don Service's vision to create a new ecosystem of hemp for the city of Newcastle, Pennsylvania. The small post-industrial city surrounded by fertile agricultural regions has the potential building stock and infrastructure that could be revitalized for a hemp building economy. The group, Don Services and Laurie, worked with local farmers to grow hemp, and the plan was to establish new local processing facilities. In 2020, when Don Services purchased a small house in Newcastle for Project PHA Hemp Home, we were excited to explore how this house could be a prototype for a Hemplime retrofit and a demonstration for other communities. Like many post-industrial cities in the US, there are many vacant balloon-framed housing stock, with many vacant balloon-framed housing stock, waiting for a better future. Renovating existing buildings is important because renovation has a lower carbon footprint than new construction. When deconstruction began, it revealed that the existing materials in the house were mostly derived from petrochemicals. So you see the vinyl siding, a lot of vinyl paneling, and the vinyl wall linings, tiles, plastic blinds, and laminate surfaces. When the materials were stripped away, we saw not only the natural old wood, but also evidence of fire. Some of the structural members had to be replaced. You know, this is one of the common challenges of renovations, the things you discover as you start to take away all of the finishes. We learned from Cameron about the Easy spray system to quickly blow in the walls of the entire house. The initial wall detail was to fill the wall cavity with Hemplime and create a simple 3 to 4 layer wall assembly with lime plaster on the inside and the outside of the wall, because lime plaster is a highly efficient vapor barrier. In the end, we used a rain screen from locally milled hemp block instead of the lime plaster on the exterior to allow the Hemplime insulation to completely dry out.
The interior was finished with lime plaster, so that created this breathable wall because lime plaster also absorbs toxics and VOCs from the atmosphere. And then we worked with manufacturers of healthier products to donate healthier finished materials to increasingly reduce the toxic emission indoors. So we used hemp flooring that was actually made from the hemp from Newcastle, and Laurie maybe has told you about that. Lime plaster wash the walls, and solid granite unfinished countertops to avoid PFAS chemicals that are typically in surface treatments. We also used pure bond formaldehyde-free plywood in the kitchen cabinets and simple furniture and fittings. This furniture was all Second Life. And then simple ceramic tile, which also does not have any kind of VOC emissions. We also designed mechanical fasteners instead of glue to reduce the use of adhesives, which then reduces the use of reduces toxics even further in the interior environment. So there's many takeaways from this project, and we put together a booklet about it and lessons learned, which is available for free on our website, and we'll give you the link later. After opening, we worked with the industrial hygienists nearby in Pittsburgh to conduct indoor air environmental quality testing so that we could gain data about this improvement. And we came up together with a long list of possible toxicants that we'd like to see the levels of. And we did this experiment by comparing the PA hemp home, which was newly finished, to a similar sized control house nearby that was made all of conventional building materials, including vinyls and plastics. They then produced a report for us and a very thorough environmental quality assessment. And the most significant finding was really interesting, which was they identified a 400% reduction in formaldehyde in the interior air, which is significant. So looking back, at the start of the design and construction process, there wasn't any guidance in local building code for hemp-lime construction. So this slowed the filing process. It was a long process to make this building. I'm sure you've heard. The PA hemp home was used, though, as an example and supporting documentation for the proposed 2024 Hemplime Construction Index for the International Residential Code. And this is super exciting. And, I think what's really important to note is that there is really a great spirit of collaboration in the U.S. Hemp Building Association and all the associates. And because of their continued support, this kind of movement is happening to have hemp lime be accepted into the building code in the United States. Also, just this week, we heard from the U.S. Hemp Building Association that in additional to the hemp lime being accepted into the IRC, they're also creating a model spec to be used in commercial buildings beginning in 2024. And you can find this on U.S. Hemp Building Association .org or USHBA.org. So there's a lot of great technical data there that you could use if you plan to use hemp lime in a construction project. At Healthy Materials Lab, we mapped the system that would be needed to create a hemp lime, viable hemp lime building industry in the United States. This diagram speaks to the complexity of launching an agriculturally plant and mineral-based materials ecosystem that creates the new materials and new ingredients for buildings. Today, fast forward to 2022, although there are farms planting hemp across the United States, hemp cultivation has actually declined while the industry waits for guidance from the federal government on the regulation and use of hemp products. Total hemp acreage is small, just slightly larger than the area used to grow Christmas trees. So while there's a huge value from hemp derived from CBD products, the demand and value of hemp hurd is still quite low. And we're looking to change that. In contrast, there is countrywide access to limestone and processing to create lime products. So that's a positive. After completing the PA hemp home and looking at the analysis of that whole process, that led us to contact a handful of other architects and builders who very generously agreed to allow their experiences and their construction details to be published. And so our initial research, as well as these case studies and wall section details, are in these small publications and downloadable for free from our website to be used as a resource for kind of open source detailing for other architects and designers. The next step we know is that facilities around the US may open up, just like they have in Europe, with mass-produced hemp-lined building products that are precast. We imagine this will create new jobs and a whole new industry. And in the US, there's a potential for workforce development in the masonry trades, which are on the decline, but with the use of hemp-lined products, the masonry trades and the plastering could increase. This needs our attention. We already know that the International Masonry Institute is keenly interested in these opportunities. So we're living in critical stages of fundamental design and cultural transformation, driven by this new paradigm of regenerative materials and energy to meet the ethical and moral obligations of reversing global climate change. We need to reverse the course of recent history to begin to live with and for the planet and all people by reducing carbon emissions, removing pollutants that are linked to those emissions, restoring habitats destroyed by industrial production, and rampant urbanism. Building homes can be central to this change. Through the building of healthy, affordable housing, we know that we can address the toxics, carbon, equity, and loss of biodiversity issues. And as we improve materials for buildings and building systems, we encourage economic development, workforce development, profitable agricultural systems, new materials and product development, and healthier lives. This work requires the deep thought and wisdom of all of us, but together and collaboratively, we can positively change the world and the way that we build. We're committed to creating a more integrated, equitable, and delightful place for everybody to live. We look forward to hearing from you over the next days and how your work is at the forefront of this change. And we need to make this ubiquitous material the hemplime, a ubiquitous material in North America. And we know that Pennsylvania can lead the way. Thank you.
Thank you.